know what is happening here. Answer for that, I think it's okay, though. Yeah, you can see that. Okay, cool. My motivation for giving this talk is is currently in the Scala ecosystem are happening quite interesting efforts and initiatives in regards all the tooling ecosystem surrounding the language. And so most people is not aware of all these things that are happening. Most is happened for the last 2 years. Most of the work is the last year. And yeah, the aim of the story is to create the awareness that exists more things beyond SBT and the default tooling that we are working with in the Scala program. For questions and comments, you can go on slido.com. With the tooling is the code of the room, and you can ask right there. I'm going to check that on the end and answer all your questions in this page. We can do it also in the normal way with the microphone or something. So what we need tools for? Every day we use different tools in a daily basis for different things, like reading our code, compiling and testing, and hopefully a lot of different tasks for different needs that we have in our jobs, or even in our personal projects. We need tools that help us to create code and be able to publish the binaries and be able to share that code, be able to test it, to do a lot of things with that, because just the code in my machine, it doesn't give value to anyone. We need to deploy that and building and versioning and do a lot of tasks surrounding that code to make it valuable. So that's why this tooling is important to improve our productivity. Because in a programming language that has a poor tooling experience for us as developers, we need that no matter how great this programming language is, if the tooling experience is awful, we are going to have a decline in our productivity. So we are going to struggle for doing all these different tasks, and our productivity is going to be affected all for that, and we need most of the time, need to focus on the actual writing the code to solve our problems or the business problems. So in these other ideas, we want tools that increase our productivity or at least not affect that in any way. So these tools has to be flexible enough to adapt to our particular workflow in the way that we like to work every day. It don't force us to change the way that we like to do the things to their particular vision instead. Because this also will have a learning curve and a community overhead to learn this new way to do the things. And this also going to affect our productivity. So the last efforts in regards to this tooling, in particular in the Scala, this is a snapshot from Metals. So here we can see the feedback cycle for this particular implementation on LSP. I'm going to talk about that in a moment. So also we want these tools give us feedback continuously and in near real time, so we can get all the information in first hand in order to make adequate decisions about how our code is working or not, or is compiling errors or warnings. So LSP is a language server protocol. It was defined in Microsoft in 2016, Now it's quite popular. It has support for more than different, like 20 different languages. The idea here is to define a protocol between our particular editor or IDE and the language that are going to use. So this works like client-server architecture. So our editor or IDE is going to be the client, and this protocol serves a bridge between the language itself to get information about things like what are the symbols, the keywords, how to make things like verify the code or formatting, the compiler warnings, and so on. So this protocol helps to create a more flexible way to adapt a particular language to whatever editor we want to choose, as choosing an editor is like a very personal decision to make, and it's not always the same thing for every developer. So from the point of view of a tooling author, you have the flexibility to just create one instance of this language server protocol, and this is going to adapt to every editor that supports this protocol or every IDE that has support for that. So you can only, as an author of tooling, you only focus on the real problem and on the particular implementations for all the editors that are in the market. So in the slide 13 is asking is it working, and yes, I can see your questions now. So this implementation of the protocol is going to send the request from your editor or the development tool as JSON RPCs to the language servers, and you are going to have an asynchronous communication between them. So every action that you make as a user or in your editor when you are saving your document, for example, the language server is going to reply with the different requests that you are making. For if you are looking for a particular instance, the language servers can respond you where in the base code is the location of that symbol in particular. So this gives you the advantage to also you can connect to different language services at the same time from just one editor. So all the responses is going to be in parallel, and at the same time for building like cross-platform programs if you have that need, is also possible to work in that way. In Scala in particular, for now, it was in the past a very initial implementation of LSP by Julian Drasgos, and these were from the inspiration for metals, that is from the Scala Center, I think. And Dottie comes from with this tooling in mind from the beginning, so he has his own implementation on the LSP. For SBT, since the version 1, they create an instance servers for when you are running SBT. So the more popular editors and IDEs in the Scala community has now support for this protocol. So now it's quite easy to start using it, regardless the editor that you are using now. So as for metals, that stands for meta programming and LSP implementation. Right now has a very decent amount of different features for ID like that we like to use every day, like going to definition. And here, as you can see, you can navigate using this VS Code. And you can navigate to all the different signatures or the implementations. The main idea behind Metal is to address the common complaints in the Scala community in regards the building tools that is building more like an overhead in terms of machine use, in terms of CPU cycles and memory that is very high. For instance, like IntelliJ is using like too much memory. It can be really slow at the beginning while indexing our code base. So the idea with Metals is to skip that problems and start working in the code right now without using too much of your resources. And at the same time, gives you a rich feature like ID features to navigate your code as usual, but without sacrificing these precious resources. Metals can also have this particular mouse and hover information that gives you not only the signature or a particular Scala expression, but also is able to evaluate the types, the return times of the particular expression, so you can know how this is going to work, as it gives you the signature and how to use it. Also has as you write, you are collecting symbols from different classes. Is not in this code the required import is going to add it automatically, and also for paramachine expressions is able to complete if you have a select trait or any other IDT is going to complete exhaustive parameters there, and is compatible with whatever other building tool that you are using now, whereas SVT, Mayborn Grading, and Ibermill. For in another release, they're going to implement the booger adapter protocol that is something beyond the LSP that is going to give you the ability to debug your programs with prompt breaks, running your code and the test right in VS Code. Also the capabilities from Worksheet to have an interactive feedback cycle as you start coding, you got all the evaluations right there. More of this is possible because they leverage another tool, which is called SemanticDB, which is aimed to present the meta information from the presentation compiler of Scala to these tools, so you can be able to pour all this information in actually without needing a running compiler. So in this order idea, you can get a boost in the information that you need from the compiler for the tool, but you can actually make this information portable and expose it like for an API. So the other tool that needs this information from the presentation compiler is not going to recompile all the stuff. It's got all the metadata that is required there, so it doesn't need to run actually the Scala compiler, so they can be faster just because of this SemanticDB tool. Another build protocol that is going to use in these tools in order to communicate with the compiler is called the build server protocol. That is actually an extension on LSP. The idea here is to communicate an instance from ELSP with BSP. So you can get all the information from your building and get it over that to the editor that you are using, so you can get the information from the compiler and the building process, or information from your dependencies that you are using. So in the Scala, the implementation in particular for this protocol is called Bloop. This has native integration with SBT, MyBurger, and MIR. So the idea here is that when you make a change in your editor and your base code, this is going to set a request through the language server, and this is able to communicate with Bloop, which is the build server, to get the information about the compiler, and so you can get feedback about if your code compiles or not. The great thing about this tool in particular is that you can catch all the side effects for a compiler process. So in these ordinary ideas, you are getting at the end have a hot JVM instance with all your compiler information. So you can eventually you are going to get faster and faster incremental compilers, as this instance of the compiler inside Bloop is going to keep hot, and you don't have to write recompile all your base code in this instance. For example, in SBT, if you put this server on all the time, you are going to see an increment, a reduction in the compiling times, but it's quite easily to get this instance that is running on SBT server called again. Like if you do a reloop or you just restart the SBT instance that you are using, all the one process for this compiler is going to get lost. So in the beginning, you are going to end compiling the things, but you are going to see that it's taking too much time to do the freeze compiler cycles. On the contrary, Bloop keeps all these instance hot, catch all the change that is made in the compiling process. So always you are going to have a hot compiler or a hot JVM instance, so you are going to reduce this compiler time every time you are using Bloop for this task. So also Bloop can make concurrent compilation for different instances or your editor, so it's possible to have these different instances at the same time. So you can run different services, compile different services at the same time in the instance without needing another instance of this build server. And it's always to do differential incrementing compiler, as you just change a little thing in your base code. It's not going to create a new compiler cycle entirely. It's only going to create to recompile all the difference that or the sources that change, the dependencies of that in Cascade, but not all the base code that you got instance in there. So the compiling the duplication is also a capability that if you send two different compiling requests to this server, he is able to see that they had the same side effects in terms of the building. So it's going just to run one of these requests without doing unnecessary work. And helps also integration with Cintiq, which is a tracing tool. So you can like observe your compiling process to see for bottlenecks, which parts of your code are taking too much time to compile, and if you can't do anything about, like if you can, for instance, optimize, I don't know, implicit research or something like that. That is mostly the kind of things that takes much time to compile in Scala. So you can get all this observable information there and get the metrics from Cintiq and be able to monitorize the compiling process if you want to reduce the compile times. From the latest versions of SBT, they have really great improvements in terms of dependency management that now is using Cursor out of the box that enables to download the dependencies in parallel. And so they got support for the latest JDK and has improvements in the class load management that was problem that and sometimes in the previous versions we were errors or taking too much time to resource certain binary incompatibilities. Another tool that was came out the last year, I think, is called MIL. This tool is based on the ideas from professional programming. Express a build process as a functional program. So relays all the ideas, the design of this build tool as a pure functional program. So you are going to end like taking advantage of the things from functional programming, like immutability or reference and transparency. In your build process, right? Also comes from with support for Bloop, that is the install for BS2. And the latest release, they add support for Dory. This tool in particular is quite new. I was like aware of this seed exists like 2 weeks ago. It seems very interesting that it has a very good support for large but quite modular projects. So you can describe in this term, in a term file that is a configuration file that is more or less kind of similar to a YAML. You can in this file, describe all your building process and how the modules are going to be organized there. So you can, like in a quite succinct file, describe all the dependencies and you scale folding for the different modules of the project. So you can end like having a really short file for all this configuration, like comparing with this boutique, with normally his DLC is quite large, and Morse is also like creating a complete Scala program just for that. So if you have the particular need to create a particular project that needs to be compiling different platforms for the JVM or JavaScript and cross-compile your different modules in this project for different versions of this JVM instance or for different versions of the Scala, it's very easy to achieve that using this tool. And as you have quite modular configuration, so you only need to describe the versions, the different versions that you need, and here automatically is going to create all the configurations that you need for that. So you can, in the end, after running it, you are going to end with all the configurations for IntelliJ IDEA, so you can open it there, and it's like ready to use. As you can skip all the building process for IntelliJ and get all in just the code base to navigate through. And for the dependency resolution, is also using Cursor for parallel downloading and management. And in the latest version, they implement the BSP protocol using natively. Instead, before they were using a command line communication with Bloop, but now it has the instance for the implementation of BSP, and they are using SIO for that. So it's a really particular case of use for this library, as the communication with the build server is going to be asynchronous, so you can all the time like pulling all this information according that as the user is going to make change in the base code. So it's quite a good example using a retrying policy for this particular use. Also, in the Scala community, we have some teams that are working with monoreports, so they end with very large code bases. So normally these the other tools are not like quite fast enough for these scenarios. So we have other build tools that are more aimed to these particular things, like Punks and Baser, that are more faster in these scenarios. So they are using they take advantage a very hard caching process, and they have managed to end these monoreport environments. Also, for Bazel, it's quite the same thing, except that with Bazel you can end in like exposing a server for your building process, that we can guarantee you a reproducible builds, as they are going to catch all the side effects, the change that made in the configuration, and the burn IDs for different builds. So you can create certain guarantees that your build process is correct or not in terms that you actually need. So basically, as a wrap up, right now in the Scala community, we have different solutions for these particular programs. Yeah, I got a question here. Can you interrogate metals with IntelliJ? Yes. No, sorry. Metals with IntelliJ. Metals, you can actually integrate IntelliJ with Bloop directly through BSP to no longer leverage on SBT to compile your code or running it. But Metals aims to the other editors that don't have like native support for Scala. And in the case of IntelliJ, they require all the compiler internals to be able to communicate with the Scala presentation compiler, so they can create a communication with that to get all the features that we need for the symbol, keywords, the compiler information. But I think it's not possible to combine that, and also you don't really want to do that, actually, because it is like a very different approach in terms of the protocol they are using, and the communication is not into that. So any more questions, maybe? Well, if not, there's more information in these links. So I'm going to share this after the talk. Thank you.